The next talk is from Jadyn, and she will tell us about the magic behind one-click deployments. Like, I think it's wonderful to just, when you do server infrastructure, you do one click and the server's just there, and you don't have the hassle of managing it by yourself as normal. We also have a signal agent for your questions later. You can post with the hashtag CCCCamp23NordX. Then we will see your questions. And now, have fun for the talk.
Okay, let's just head back to the first slide. And then we can start. Well, it's buggy. Okay, welcome to my talk, the magic behind auto-deployments. As Leona already said, auto-deployments is something that most of us have interacted with before. Yeah, but let's start. First thing, I'm Jadyn. My pronouns are she, her. I'm 22. I work in cybersecurity, and I do lots of things with computers and hardwares and stuff. You can find me on Chaos Social, Jadyn at Chaos Social, and on my website, as you've already seen, where you can also find the slides. What is an auto-deployment, and what is a one-click deployment? We will have about 4 parts in this talk. First, what even is it? Then, how does it work? Then we will try to demonstrate it right here with real hardware in real data centers. And afterwards, there will be a Q&A session where I can hopefully answer most of your questions. And if I can't, just hit me up after the talk or on social media or via email or whatever. Okay. One-click deployments are fully automated deployments. What does it mean? It means that we can spawn anything like a VM or container, IP addresses, DNS entries, and much, much more, like user management, firewalls, software configuration, monitoring, and anything you can imagine. The whole thing is pretty easy, but you have to get some key ingredients first. To allow access for an automated system on all your devices and access to APIs, you usually need some kind of root access, usually done with SSH, and you need your deployment sources, which are usually from just a Git repository where you have your config files and your scripts, and then there's your source of truth, which is, in my case, Netbox. And then you have the big issue of secret storage. You have to generate secrets on demand for root passwords, user passwords, and a lot of other things, databases, everything. And that is most easily done with a utility called pass, which is just using GPG to store your credentials and encrypt them, so you can just put them in a Git repository and everything is fine. The easiest way to get that is just get a dedicated host. It doesn't have to be in a data center. In my case, it is. And you just plug in a small YubiKey. Most of you probably know what that is. It's a small device you plug in via USB into your computer, which can store your encryption keys, your private keys, in a fashion that doesn't allow them to get off there. They are on that small USB stick, and nobody can get them. Well, you could, but it's really, really, really hard. Okay, inner workings. You need to gather some data before we can even start with your deployment. This data is usually provided by some kind of source of truth. Netbox is my favorite way of doing that because handling config files is, to be honest, quite a pain to get them everywhere, and writing in config files isn't that easy either. And as I said, we want that to work with one click via a web UI, so writing config files is not that easy. And in your source of truth, you usually store things like your host name, network interfaces, IP addresses, gateways, DNS servers, your hypervisor config like memory, or if you get your machine from some provider like AWS or Hetzner or something, you need to know how many cores you need, how much memory, and such things. And you also want to know which services you want to install. The second step is gathering the secrets. I've implemented a very easy way, which is based on the passwordstore.org utility. As mentioned before, it just uses GPG. And I've written an Ansible module to dynamically generate secrets and store them in an encrypted way. This is just an example. You have your Ansible secret storage, which contains your host secrets, which are individually for each host, and also your secrets like databases, super user passwords, and the host root password, of course. And your static secrets like API tokens, DNS access, and things that you don't want to generate on demand because the secrets will stay the same in your environment. Second step is to configure your hypervisor or your VM of some sort. For that, I'm using Proxmox, but you can use AWS or Hetzner or whatever. It's pretty much just an implementation detail. You need to spawn and configure the hardware, which usually is done with a simple API request to your favorite provider or your own services. Then you already get the first issue, network configuration. You need to probably set things from your IP addresses to your MAC addresses and all of that. That is usually handled by your provider or by your hypervisor. And Netbox or your configuration management just tells you which IPs do I want, which IPs are free, which MAC addresses are free, and you just generate that data on demand. And you already set your default password. Usually, you either get a default password from your API request, or you send one with it. Or you send your SSH public key. After that, your device is spawned, and the first thing is we SSH in using our root user that we just created. Then we run things, the usual setup. Everyone does it probably, like you're installing your packages and your default packages, you're upgrading, installing the firewalls, making firewall rules like allowing SSH, and allowing your services that you want to install, for example, a web server, which would need port 80 and SSL ports. And then you ensure that your root password is matching the one that you have in your database, in your password database, and then you configure stuff like sudo. Like, that's the easiest and basic things. You could stop at this point, and then you just have a machine that is running somewhere in the internet or on your own network, and you have a root password, your SSH keys are deployed, and you can start from there doing your stuff via SSH. But then we have things like DNS. So we gather, for example, our SSH fingerprints and put them in DNS, which is a neat security feature. For those who haven't heard of it, you can put your SSH fingerprint onto your DNS, and SSH will contact your DNS server and validate that the host matches those keys, which will just ensure that your DNS isn't doing something weird or you're connecting to the wrong host or something. Then, of course, we set our A and quad A records, our C names if we need them, and everything else. For example, we saw that. For example, you can also set the Prometheus DNS records, which are just SOV records that allowed your monitoring to learn about new hosts. We will see that in action soon. Yeah, monitoring records. And then we get into the nitty-gritty of the whole thing, configuring and installing services. In my example, I just want to install a Netbox instance. So we need to ensure that we have a Postgres database so that your service can store all its data. After the database is created, we have to install all our dependencies. And we just do that via Ansible. And after that, we configure our service. And then we run some other small stuff. And then you bring it up. The whole thing is running. You connect via your admin software of choice. And then you create your super user. And in the end, your password database will just have admin and your randomly generated pseudo user password or admin password for the service you need. And you never have to touch that host with SSH yourself. Everything is just in your password database, which you can integrate into your password manager, and it's done. You don't have to connect to the host manually. Afterwards, we also want monitoring. Monitoring is a very important but often underlooked thing in IT security and also in IT in general. I don't only need the service to be up and running, I also need to know if it's well. And if it's having issues or the drives are getting full and stuff like that. So you usually have something using Prometheus and Grafana or some variation of that. And as we've seen before, we just add the SRV record to our Prometheus zone, and Prometheus will automatically discover our new host, and we don't have to do anything on that part either. Then, even a more overlooked part is, what do you want to do when you get rid of the whole thing? There are DNS records and monitoring things you have to remove. And also your secret storage has to be cleaned up. So we will unregister the whole thing from monitoring, delete the DNS entries, and then remove the VM or container from our hypervisor, and everything is removed, and it's done. I've sped through this part quite a bit, because now we're going to see it happen in real time, hopefully. So we start with our Netbox instance. That is the way I have it configured. Okay, it's really loud over there. So I've created a new virtual machine with the name cccam23.jupyter.caffeinatedlabs.net. Jupyter is my hypervisor, and this is the hostname of the virtual machine we want to create. As you can see here, we have our network interface already. Very nice. Do we have broken IPv6? Maybe. Yeah. No IPv6 over here. Very nice. Let's check. Yeah. Well, no IPv6 for me. It's a modern standard. Like, it's way too new to be supported everywhere. I shouldn't have expected it to work. I'm sorry. Okay, that is really distracting over there. Well, do we have IPv6 now? Well, that's embarrassing. I'm on the Wi-Fi right now, so I'm trying to get a connection. Let me just test this. Yeah, I've unplugged it. And I'm on the Wi-Fi, but Wi-Fi doesn't have IPv6 either. Thanks. I'll try. Let me just try. Let's reconnect. It's working. It's working again. Turning it off and on again has worked. So let's see. Well, internet is real fast today. Okay, we have our thing. Yeah, it has worked. Very good. And the SSH connection is also up. Okay, we can see our Ethernet device with our public IP address and our pre-configured MAC address. We can also randomly generate it on demand, but I've pre-configured it so that it doesn't change quite as often and the op tables don't get full as much when we... Yeah, I can... Yes, give me a second. Is there light theme? Light mode. Okay, can you see it now?
Yes.
Okay, perfect. Let's go back to the interfaces tab. And let me just close this. We have our MAC address and our Ethernet device and our IP address. Then we can go over here. We can see this is our host name. The device is currently offline because we want to pre-configure it. Then we have selected our Debian 12 as a base image. Down here are some of the Proxmox features we want to configure. It should start at the hypervisor boot. It doesn't have a Proxmox VM ID yet, but we will see that this field will get populated once we have run our script. And we have configured on which cluster it's running, on which node, and all of that. And we've also configured our virtual CPUs, our 2 gigabytes of RAM, and the 8 gigabytes of storage. There's nothing else configured yet. So everything you see here is the config. Now we will go over to the SSH session and run the whole thing. I'm currently connected to the host I've described before, which is has the YubiKey plugged into it, so I could even unplug this one if I wanted to. So let's go to our deployment. This will happen automatically with a webhook, but for demonstration, I will show it to you this way, and also the script will pause sometimes so I can explain what's happened. We have a deploy and then our environment. And then we can just run deploy. Okay, let's deploy this machine. First thing is we are decrypting our secrets. Then we are installing our Python dependencies for the Ansible controller. Then our Ansible script will talk to Netbox and figure out which machine we want to deploy and with which settings. Then we are cloning our secret repository and generating our secrets. As we can see, we have generated our root password, for example. Our root password has been generated, and where is it? Yeah, our TC key for DNS challenges has been, and DNS access has been generated. Yeah, up here we can see that our secrets underscore host underscore root password has been generated. Yeah, let's continue the deployment. The next thing is we will ask Netbox about the gateways that are in this network, which DNS servers to use, and records and other DNS configuration. Then we can also look, some tasks are skipped. That is a quite normal thing in Ansible. We are now trying to configure a physical device, but as the Netbox has told us, it's a virtual machine, so we don't need to run physical device configurations. Okay, now we would create an update book. Yeah, because we have selected that it's offline, now it will just tell me, yeah, it's offline and it won't deploy anything. If we change that in our netbox, change it over to online, let me just show you. If we change that over here to provisioning state, or let's just set it to active and save it, our Ansible will now get the new data, new information, and we'll try to deploy the machine. Let's switch back to the terminal and let's run our script again. Okay, same thing as before. We are collecting our initial secrets for the netbox access. We are installing local dependencies. We are now talking to our netbox, figuring out what to do. Loading our secret repository. And as you can see now, we don't generate it. The secret has been just loaded. It was generated before, as we saw in the changelog, and now it's just loaded because it was already stored in our secret database. Okay, now more stuff is happening. We are now creating our container right here. As you know, this part does take quite some while to spawn a new container. After that is finished, we will see that our, yeah, exactly. Now we update the netbox, which I can show you. Okay, netbox will now show me the new Proxmox ID down here. It has been created as container 104. And now our deployment continues. And we are now upgrading the default packages and installing the basic packages we need to have our Debian configured. Well, Debian is a bit slow today. As I said before, it's real hardware and real data centers, so probably it's the usual effect of when you show it to people, it doesn't work. But I can tell you what's going to happen next and what this means. Because we first try to connect with our user to check if the device has been provisioned before, which it hasn't. So we switch over to our root user because the access was denied with our unprivileged user. Yeah, we have updated our Debian, and then we want to install our default packages, which are, in my case, vim, curl, sudo, and tree, I think. Just the usual stuff you want to have on every machine. Yeah. Okay, now we are configuring our sudo. Now we are configuring our firewall. In my case, I just use UFV. It's in my opinion, it's the easiest way to have a simple firewall on your device. It will install the package and then automatically configure our trusted network. So everything within my IP range is considered trusted, and everything outside it is considered untrusted. That is important for monitoring access, as I don't want my monitoring data to be available from the internet, so it's only available from the internal network. And now we are rebooting our host because we have configured our firewall, we have configured our root user, and we have configured our default packages. After the reboot, we will continue. And as you can see, all of this is happening automatically. The device is rebooting, the device is being configured, and now we have reached the point where we can start our custom deployments. So first of all, we are collecting our fingerprints for the DNS, which we can see over here. We have added our Quad A record, our 3 SSH fingerprint records, and our monitoring record, which just tells the monitoring to look at this host now. After that, we will configure our users with their SSH keys, default passwords, and their permissions. You can configure many users. You could also configure PAM LDAP, for example, so you don't have to configure the users yourself, and your Linux is just talking to your LDAP for validation. Then we want to apply SSH hardening to our instance, just the default SSH options you want to enable and disable. And we are also installing fail2ban, which is just a neat security measure and helps on getting rid of all the people trying to connect to your host with bad passwords. Especially if your host is connected to the internet, steps like these are highly recommended. Okay, now we have configured our SSH. Now we don't want to install Proxmox, so we skip that. We also skip disk encryption, and those are all the services you could deploy on a machine. And only the services we have selected in the netbox are actually deployed. Everything else is skipped. Okay. Now we are installing Node Exporter and creating our SSL certificates so that we can connect to the device with encrypted and valid certificates. I can now show you, as we have configured our our monitoring records for Prometheus. I can now show you the Prometheus side of things. Let's zoom in a bit and switch to light mode. As you can see, our host has appeared. It is currently considered done because we haven't finished our deployment. And once we have finished deploying, which we can see in the terminal right here, as you can see, our monitoring stuff has been installed and configured. And now we are installing a final thing I quite like. I have a custom message of the day package, which will just display the last successful Ansible run, its git commit, and stuff like that. So you know that when you SSH into a machine, when the last deployment has happened, because Ansible doesn't deploy continuously. It gets run by your webhook or by yourself, and after that, it just stays like this. Okay, we have finished our deployment. If we check back at Prometheus, we can see that our host is now considered up because everything has been configured, and we can SSH into our host as well. Let's just SSH into this host. Well, it's not a good day today. Let's just remove that real quick. Yes. And now we can see our custom message of the day, which will just tell us, oh, I'm sorry. Okay, now we can see the custom message of the day, which will just show our... Very good. Very good, Johanna, very good. We can see our custom message of the day, which will show you the OS version, Ansible commits, and everything else. Well, that happens if you have two IT administrators, I guess. Okay, now let's just decommission the whole thing. And I'll try to let the decommissioning happen in the background, and then we can switch over to our Q&A. Yeah, the slides are on my website, and the code can be found on you can find the code on caffeinatedlabs.org. And in the next coming days, I'll try to open source as much of this as possible, so you can take a look at for yourself. Yeah, but I'm now open for Q&A questions. Yeah.
We have about 12 minutes left for Q&A. I will go around.
Okay, so how much of this is standard Ansible or at least readily available Ansible scripts? How much is custom Ansible scripts and how much is custom glue code?
Depends on what you consider glue code. I have re-implemented some modules. The biggest of those are the secret management, which will hopefully be open sourced soon. And the Proxmox API, I've written a small wrapper so you can directly interact because community general Proxmox Ansible modules try to abstract very much, so you can use them as closely to you can't configure things directly in some cases. So I've just written a small wrapper around the Python library Proxmoxer, which just passes through the arguments to Proxmox directly without any logic in between.
Just as a reminder, we can also have a signal angel. So if you watch in the internet, you can also ask a question with the hashtag ccccamp23notx. Now the next question.
How do you handle backups and restoring them if something gets broken or something doesn't work anymore?
Okay, I run a backup before every Ansible deployment automatically, which means that I can simply restore the container to the state it was before the deployment. Those backups are kept for 5 times or something like that. So you have your standard backup rotation there. And Ansible just creates a backup. In case something goes wrong, you can just restore the previous state and continue from there.
Thank you for the presentation. You said you are going to decommission the system now in the background.
Yeah.
I'm quite curious, is it like extra rows you wrote for unregistering the VM on Proxmox and the DNS entries, or?
I have written most playbooks which deal with provisioning and deprovisioning to do it themselves. You have a variable which will tell it's the netbox status variable, which will just tell you is it active, is it deprovisioning, is it offline, and the playbooks decide on those variables what to do.
So you have a complete list of all your VMs, and if one is not in the list but on Proxmox, it gets deleted.
No, I'll just show you. When we switch over to our netbox, we just change the status to decommissioning, which is just this, and now we save it. And afterwards, we can switch back to our deployment. And now the system will detect the change from netbox and delete the container. We will see also that it will create a backup before deletion, just as it would before any other Ansible run. I'll let you continue that. Is there other questions? Yeah.
Sorry. Do you have some experience on secrets management in a more enterprisey environment?
What do you mean by more enterprisey?
I mean, with one YubiKey, you just have one, but you have several people needing to access the management, a part of HashiCorp Vault. Just out of curiosity.
Yeah, you can scale the way I've done it to a small team, but the encryption is a serious factor when deploying hundreds of hosts, because every operation with the YubiKeys just takes some time. There are ways around that to use hashing for secret generation, for example. I am planning to implement something like that in the future, but I haven't implemented it yet.
Do we have any questions left?
Hello. With regards to the scope of the secrets, is it just for stuff is it stored encrypted outside the container and inside, or is it stored encrypted outside then decrypted inside? What's the kind of scope for that?
Yeah, it is stored encrypted outside the container and unencrypted inside, because usually the config files don't allow for encryption. If you have a config file that allows for encryption or hashing, you should do that, and I'll do that. But sometimes if it's not possible to do it, it will be stored unencrypted inside the container and encrypted outside.
How much time does it take to set up a whole new service which contains about 3 or 4 new processes which need to be started, a database, and so on? How much time do you need to set up all these Ansible scripts and all this stuff if you know how to deploy everything?
So you mean like if I, for example, have a service that I don't have a script for, how much time it takes to write an Ansible playbook to run it?
Yes, of course, if you know how to deploy the service.
Okay, so yeah. As most services are usually the same structure. You have your systemd units, and you have your code, which has to be installed some way. That is usually a copy-paste job of just taking another similar process and just changing a few things around. So a basic role can be done in about an hour, and a more advanced one in, like 10 hours to a few weeks, depending on the size of the project. Okay, as we can see before, we have now changed our state. The Proxmox ID has been given back to the pool, the device is offline, and the container has been removed. Final step here is to remove our DNS records, which will just remove the old records. And then the rest won't run because it knows that the device is now offline. And one final thing is to remove the entries in your .ssh known hosts file. Those will be removed, and now you can redeploy your host under the same IP address without SSH shitting its pants, to be honest. Okay, are there any more questions?
You use containers. This works also with normal Proxmox VMs?
Yes. The configuration is a bit different because in VMs, you usually have to configure the IP addresses inside the VM and not inside Proxmox. But that's just a change to your deployment playbooks. And you can make that have that work as well. You could even go as far as to do that with a host you just screwed into your rack. So you just install your base system, and then from there you can deploy just like any other machine. Any further questions?
Okay, then thank you for your talk. It was interesting I think for all of us, and a huge applause for Jadyn.